Introduction. For the introduction, we have logical connective. First of all, statement or proposition. It is declarative sentences that are either true or false but not both. Secondly, use lowercase letter of the alphabet to represent these statements. And finally, a statement that contains connective is called compound statement.
Next is logical connective symbol. So there are 5 symbols. Number 1, conjunction or and. Second is disjunction or. Number 3, implication, if then. Number 4, biconditional, if and only if. And the last one is negation or not. So next is the definition for truth table and truth value. So truth table is a table which represents the true value for the compound statement based on the combination of all the true simple statements. And true value is a value of certain statement whether it is true or false. So if the compound statement P and Q, we can write it in symbol P, V upside down, Q. And if the statement give P or Q, we can write it in symbol P, V, Q. If the statement is P then Q, we can write it P arrow Q. And if P is and only if Q, we can write it P with two-sided arrow Q. And the last one, not P or not Q, we can write it curly line P or Q. So the true value and the true table for negation, if P is true, and not P is false, and if P is false and not P is true. Second is conjunction. If P is true and Q is true, then P and Q is true. If P is true and Q is false, then P and Q is false. If P is false and Q is true, then P and Q is false. And if P and Q is false, then its conclusion P and Q is false. So disjunction or if P is true, then Q is true, P or Q is true. If P is true and Q is false, P or Q is true. If P is false, Q is true, P or Q is true. And if P and Q is false, P or Q is false. So next is implication if then. If P and Q is true, then if P then Q is true. If P is true and Q is false, if P then Q is false. If P is false and Q is true, if P then Q is true. And if P and Q is false, if P then Q is true. So the last one, biconditional, if and only if. If P and Q is true, P if and only if Q is true. If P is true and Q is false, P if and only if Q is false. If P is false and Q is true, P if and only if Q is false. And if both P and Q is false, P if and only if Q is true. So this is the definition in logical connective. So number 1, tautology. Tautology is a proposition involving a logical variable that is true in all cases. Number 2, contradiction. Contradiction is a proposition that is constructed to be false in all cases. And the last one is contingency. Contingency is a proposition that is not tautology and not contradiction.
Okay, for the example 1, construct the true table for the statement below. P or Q and not P, implication Q. Okay, for the answer, P or Q and not P, implication Q. First, we need to do a truth table. For P, we have true, true, false, false. For Q, true, false, true, false. Not P, false, false, true, true. For P or Q, we have true, 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 false. Firstly, we need to do P or Q and not P. For the answer is false, false, true, false. The last one, we can get the answer for P or Q and not P, multiplication Q. The answer is true, 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 true.
Next, example 2. Construct the truth table for the statement below. If P or Q, then not R. For the answer is P, true, 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 false, 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 false. And then Q, true, true, false, false, true, true, false, false. And R, true, false, true, false, true, false, true, false. P or Q, true, 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 false, false. Not R's, false, true, false, true, false, true, false, true. And lastly, P or Q, then not R, false, true, false, true, false, true, true, true.
So, for the next question, example 3. Construct a truth table to determine whether the statement below are a tautology, contradiction, or contingency. So, the question is, open bracket P or Q, close bracket, and open bracket not P and not Q, close bracket. So, this is the answer for the question. As you can see, we construct a truth table to determine whether the statement below are a tautology, contradiction, or contingency. So first, P, true, true, false, false. Then Q, true, false, true, false. Then not P, false, false, true, true. Then not Q, false, true, false, true. Then P or Q, true, 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 false. Then not P and not Q, false, 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 true. And last but not least, open bracket P or Q, close bracket, and open bracket not P and not Q, close bracket, false, 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 false. So as you can see, the last answer is all false. Then we can conclude that the statement is contradiction.
In conclusion, logical connectives allow for unambiguous representation of statement, making complex arguments easier to understand and validate. Logical connectives are analyzed through truth table to determine the validity of compound statement, which is fundamental for constructing tautologies or detecting fallacies. And logical connectives help translate intuitive reasoning into formal logical expressions, which are essential for rigorous mathematical proof.